What is Scikit-Learn, or you can say sklearn? So this is actually library which are using whenever you want to perform whenever you want to do any programming in Python at the time of Python programming project, Python learning project. Okay, so basically we use this library in Python programming whenever you want to develop any project in Python. Okay, so basically what is actually library? I think library, we heard this term library. We all of know the library whenever we study in the college. So library is here, and library is a collection of so many books. Whenever you want to access introduction of AI, so then you can go library along with your whenever you want to access the introduction to artificial intelligence in your library, college library. So you have to access the library. Okay, so you can go there and give some proof because you are the college student. So obviously you have the college ID. Okay, so you can access the your college library. Okay, you can read introduction to artificial intelligence book, and so many other books are available there. Whenever you want to access machine learning introduction, whenever you want to access object oriented programming, so you can choose your choice. According to your choice, you can access any book in your library. Similarly, whenever you want to learn about the Python, whenever you want to develop any Python programming, whenever you want to develop any project in machine learning, AI, and DL, so there is some libraries required to develop your program. Library is a collection of methods, you can say. Okay, whenever you want to use a Scikit-Learn library or Scikit-Learn library, whenever you want to access matplotlib library, so there are different function. Okay, there are so many library we can use. So we will discuss one by one in uh, upcoming slide. Okay, so firstly we discuss here Scikit-Learn, or you can say sklearn. It is a basic, most useful and robust library for machine learning in Python. Most useful and robust library. Okay, so each and every, whenever you develop any machine learning projects, you must be require sklearn or scikit-learn libraries. Okay, it provides a selection of efficient tool for machine learning and statistical modeling, including classification, regression, and dimension reduction via a consistent interface in the Python. Okay, so it's a tool, you can say, for the selection of efficient tool for machine learning and statistical modeling, which are classification. As we know, the classification, we already taken an example of email classification like ham spam classification. Okay, and another example you can say pass fail. Okay, how many students will be passed in upcoming semester? You can say you can develop a machine learning model. In that case, we require the uh, data, historical data of that particular organization whenever you want to develop the classification model. Okay, hard disease prediction model, you can say, you can develop. Okay, so there is required some data. Okay, and regression is also there. What is the example of regression? Regression weather forecasting is one of the example of the regression. Stock price market prediction is one of another example of the regression. Okay, there is a output in the form of continuous number. Okay, clustering is one. Clustering is also there. So clustering, for example, Netflix. We already discussed this example. Whenever you want to search any movie on the Netflix, for example, you watch Money Heights today on the Netflix. So after watching this movie, you can log out from the Netflix. Whenever you open Netflix after 2 days and 1 week, so it will be suggest to you according to the your choice. Okay, because your account has some history, okay, of yours. So according to that history, it will suggest to you any other movie according to the previous earlier watch. Okay, and dimension reduction is also there. Dimension reduction, that means it is a function that we can say uh, high dimension to low dimension conversion. Okay, PCI is one of the best example to understand. We already discussed in previous lecture. Okay, we use always a useful feature, and unuseful feature we cannot use, you can say. So for example, if you have a data set, 1 lakh attributes are there, but 1 lakh attributes are not useful. Okay, some of the attributes, some of the features are useful. So we can select select these features, and you can develop your model according to. Okay, and Scikit-Learn library, which is largely written in Python, and which is built upon NumPy and SciPy and Matplotlib. NumPy, that means numerical calculation. Whenever you want to perform any numerical calculation, and then we can use NumPy, and SciPy whenever you want to scientific calculation, so we can use SciPy. Okay, Matplotlib basically we used for the visualization purpose. Okay, so installation of Scikit-Learn or sklearn, you can say. If you already installed NumPy and SciPy, following are two easiest way to install Scikit-Learn. So one of the method using pip. Following command can be used to install Scikit-Learn via pip. So this is the command which we can use to install Scikit-Learn. Pip install uh, des capital U Scikit-Learn. Okay, using command prompt, you can just write this command and hit on enter. Start the installing process of the Scikit-Learn. Another one is using Conda. Okay, using Conda, following command can be used to install Scikit-Learn by Conda. So this is the command Conda install Scikit-Learn. Okay, just write this command on the command prompt and hit on enter. Install installation process will be started here. Okay. On the other hand, if NumPy and SciPy is not yet installed on your Python workstation, then you can install them by using pip or Conda. Okay. Another option to use Scikit-Learn is to use Python distribution like um Canopy and Anaconda, because they both ship the latest version of Scikit-Learn. Okay. So remember this thing. Whenever you want to work, whenever you want to work on the Anaconda or Canopy. Yes. What is actually data set? We already discussed about the data. Whenever we want to develop any machine learning model, whenever you want to develop an project, which is based on the machine learning or deep learning and AI and all. So firstly required some data. Okay. For example, if you want to develop a heart disease prediction model, so must require some data here. Okay, previous historical data we use there, and pre-process that data, and after pre-processing we process that data. Okay, and then we can make some logical algorithms here, and completely we build our model. After getting some new data, we will predict some new value according to that historical data. Okay, so data must be required here. So there are some example to understand the data set. Okay, whenever we use any data set, Firstly, requires the explorer of that data. Firstly, required the data information. Explore that information like iris data set. So iris data set have some information. So firstly, explore these information like data set characteristics. So first one is number of instances here 150, and that data set number of instances only 150. 50 in each of three classes. That means 50 into 3, it will be 150. So remember this thing. Number of attributes are there, 4 numeric and predictive attributes at the class. 4 numeric attributes are there. Okay. There are 4 attributes are there, and 4 attribute will be considered as numeric form. Okay. Attribute information. Attributes, there are 4 attribute, and which are, first one is sepal length in centimeter, sepal width in centimeter, petal length in centimeter, petal width in centimeter. So all these 4 attribute consider as a numeric form, because centimeter unit is always in a numeric. Okay. Class. Other information of iris dataset class. So there is 3 classes: iris setosa, iris versicolor, and iris virginica. Okay, so there are 3 classes of iris dataset, and missing attributes values are there none. There is no any missing values, and class distribution is 33.3% of each 3 classes. Okay, equally divided. Creator, who is the creator of that dataset? R.A. Fisher. R.A. Fisher is a was a creator of that data. Donor, Michael Marcel. Michael Marcel was a donor. Okay, and date of that data and July 1988. Okay, so these are the basic information band iris data set. So firstly explore out the data set, then you have to work with the data set. Okay, without any exploration, without any getting knowledge about that data set, you cannot do the you cannot develop data set, or you cannot develop any model. Okay, like second example is diabetic data set. So dataset characteristics are a number of instances here 442. Number of attributes are here. First 10 columns are numeric predictive values. There are 10 attributes which are numeric. Okay. Target attributes is also there. Column number 811 is a quantitative measure of disease progression 1 year after baseline. Okay. And attribute information, first attributes is age, and unit is of that attribute is in year. Okay. BMI, body mass index. Okay. VP, sex. BP, average blood pressure. S1TC, total serum cholesterol. S2 IDL, low density lipoprotein. S3 HDL, high density lipoprotein. S4 TCH, total cholesterol, you can say HDL. S5 uh, S5 LTG, possibly log of serum triglyceride level. S6 GLU, blood sugar level. Okay, so these are the basic attributes which are using in this, which are in this data set. Okay, there are source URL is also given here. Okay, whenever you want to access this data set, just click on that URL and you will get the data set. Another data set is optical recognition of handwritten digit data set. There are some characteristics of that data set. Number of instances 1797. total instances is 1797. Number of attributes are 64, and number of information attribute information 8 by 8 images of integer pixel in the range 0 to 16. Okay, missing attribute values are none, creator, alpidin, okay, and date are the July 1998. Source is also given here. If you want to access the dataset, just click on that URL. You will get the sorry, that dataset, which is available in UCI website. Splitting a dataset with yes. First, we have to collect the dataset. Then we have to pre-process that dataset. Then we have to go with the processing the dataset. Okay. So first step is first we have to split the dataset. So there is the method train test split method to split the dataset. Okay, so there is required training dataset and test dataset. Okay, so there is the method train and test split method, which is used to split our data into train and test set. Okay, first we need to divide our data into features X and label by. We need to divide our data into features X, okay, and label by. What are the features? Features are the attribute. Okay, as we discussed in previous slide, number of features, that means in the handwritten data set, handwritten writing data set, 64s are the features. So these are the features. Okay. The data frame gets divided into X train, X test, Y train, Y test. Okay. X train and Y train test set are used for training. Okay. And fitting the model. Okay. Training part which is used for the training purpose. Okay, and X test and Y test set are used for testing the model if it's predicting the right output or levels. We can explicitly test the size of the brain and test sets, size of the train and test sets. It is suggested to keep our train set larger than the test set. We already discussed about the testing part will be considered always less than uh, rather than training. Okay, part and testing part ratio will be 80%, 20%, 7 is majorly we use, and 75%, 25% uh, generally we can use. Okay, training test split method reside in the Scikit-Learn model selection module. Okay, so for the splitting of the data must require the Scikit-Learn model selection module. Okay, which are the syntax we follow? From sklearn dot model selection import train test split. Okay, this is the example. This is the most common approach, which leaves us with four subset: X train, X test. Four subsets are X train, X test, Y train, Y test. So first we import the data set from sklearn.dataset import load iris. Okay. From second line is we use for the model selection module for the test and training splitting purpose. So from sklearn.model model underscore selection import train underscore test underscore split. Okay, then X we use for the features and Y we can say label. So X comma Y is equals to load irs, return will be true for X and Y. Okay, then splitting perform here. X train, X test, Y train, Y test is equals to we apply a test and split method on X comma Y. That means X for feature, Y is label. Train underscore test, train underscore test underscore split on X comma Y. Okay, so splitting done here. After splitting, we want to print the size, you can say shape of the train or test, or so we want to print here train shape, test shape of features, and train shape and test shape for the label. So first line, print x underscore train shape, print x underscore test shape, and print y underscore train shape, and print y underscore test shape. After executing of this code, you will get the output something 120 comma 4. That means this is the trend shape. Okay, x trend shape. Okay, test shape, that will be 30 comma 4. That means that is the test shape. And y shape, y training shape is 120, and because this is the label, and y test shape is 30. Without setting either train size or test size, the default value kick in. Setting the test size is to 0.25 and a complementary 0.75 train size. So that will be the output look like this. 112,4 for the train shape, 38,4 for the x underscore test shape. That means for the x for the features test shape, and 112 for the label train shape, and 38 label test shape. Okay. After you will specify the size of the test set. Okay. As you can see, train and test set are splitting. We already discussed about the ratio of the train and test set splitting. 75% for the training, okay, and testing will be 25%. As there are 112 instances, and we already discussed about the shape of the features and label here. Whenever we will consider test size will be 0.25. So there are 112 instances in the X train set and 38 instances in the X test set. Some other split proportion are 80% for the training and 20% for the testing. It is very common proportion for the training and testing. And 67, another one is 67% for the training and 33% for the testing. We can also consider this. And most rarely use 50% for the training and 50% for the testing. Okay, so generally we avoid this ratio. 50% data we will consider for training and 50% data we consider for the testing. Okay, we ignore it always. Generally we use for the splitting of the data. Generally we use 80-20%. It's very common. Setting any of these boil down to defining either one or both of the argument in the train test split method. So uh, you can just see here x train x test y test equals to we applied here test and split method on x comma y. Train size will be we specify here train size 0.8. That means 80% data will be considered for the training size. Next is extend uh, X test, Y train, Y test. Test train test split method are used here. X comma Y train size zero point 0.8 to zero point 0.8 and test size is equals to 0.2. That means it is also specify the training size and testing size individually. Okay, you just write here. Another way to just you can write the test size is equals to 0.2. So that is also correct. Okay, so both three of them is also correct. Whenever you want to choose any way to write the size of the train and testing set, so you can pick any of one. So creating a validation set is also there. Creating a validation set with test train split method. So let's reuse it to get our hand on validation set, taking 10% of data from the training set. So validation set is also the part of the training set. It's not any other part. So it is also part. It is a 10% part of the training set. Okay. So this is the example. Firstly, we import the data set. Which data set we are using here? Just we are using here iris dataset. Okay, so from Scikit-Learn dot dataset import load underscore iris. Okay, from so in this line we can understand here we want to load the iris dataset. Okay, from Scikit-Learn dot model selection import train test split. We are using this line to import the test and split method using model selection method with sklearn. Next is extend x test y train y test is equals to train test split x comma y. We want to apply this method train test split method on x y features and label and train size is equals to 0.8%. 0.8 that means 80% data we use for the training here. And next line we just add here validation part. Okay, so print x train dots sorry x train x valid y train y valid and then we apply the train test split method on that x or y. X or y, that means x is the label and y, oh, x is the uh, x is the features we can say and y consider as a label. And size will be 0.9. We already given here train size is equals to 0.9. That means 90% data we use for the training here along with the validation. So after that we want to print the size of the training part, test part and validation part. So we write here print x underscore train dot shape, print underscore x underscore test dot shape, print x underscore valid dot shape. Okay, this one create a 70%, 20%, 10% split. Okay, as we are splitting 10% from the already split x underscore train. So we are actually ending up with a 72%, 20%, 8% split here. Okay, so this is the 70% part we use for the training, 20% part we are using for the testing, 8% part we are using for the validation. Okay, so You can see here 108,4, that means training part. 30,4, that means it is the test part, and 12,4, it means validation part. So let's take an example. Step to split the data. First step is import the necessary package or modules. In this step, we are importing the necessary package or module into the working Python environment. Okay. Whenever I want to use a Spider, whenever I want to use a Colab, whenever I want to use any other platform, so you can just use it and process will be almost same. So import packages. First one, import NumPy as NP. Firstly, we import NumPy. Okay. Secondly, import pandas as PD. Pandas library we also use here for the manipulation. From Scikit-Learn.module selection, import print test split method. Okay, we already discussed about this thing. Okay, step number 2, import the dataset. Here we load the CSV, comma separated value. Okay, so CSV using pd.read underscore CSV method. Whenever you want to read, whenever you want to access, whenever you want to import CSV file for of data sets, so must we use this method pd.read underscore CSV method from pandas and get the shape of the data set using shape function. Okay, using shape function. So importing data, this is the way to giving the path. For example, df considered as a data frame is equals to pd is the uh, uh, PD is the object just like the pandas library for the manipulation. PD dot read underscore CSV it is a method to access the data from your system, you can say. So your data prediction.csv is placed under the folder IML unit 2, which is under the folder 19, oh, sorry, VTech IML. This is also under the machine learning. This is also under the folder Imagen XP session June July 2023 in F drive. So this is the path we have to follow whenever you want to access print.csv, sorry, prediction.csv, your data. So firstly, we want to explore your data. Okay, then we have to follow that path, and that path will be here. Okay, to access that data. After that, we want to know about the shape of that data. Okay, so we use here print function, print df.shape. After we will get 13,3. That means your shape of the data will be 13,3. Step number 3, get x and y feature variables. Get x and y features variable. Here we are assigning the x and y variable in which the x feature variable has independent variable and y feature variable has dependent variable. So that we already discussed about that whenever we want to access any data set, whenever we want to use any data set. Okay, so firstly we explore about that data set. Okay, what are the features are there? Must know. Then we have to go with the that data set for the pre-processing and all. So x is equals to df. In that df, that means data frame area. Okay, and y is equals to df. X and y are the variable in x feature variable has independent variables. Okay, and y feature variable has dependent variable. That means depend on the area, price will be increase or decrease. Area will be, suppose area will be 1000 square feet and the price will be 10 lakh. And area whenever increase, that means for example 2000 square feet, so price will be also increase like 20 lakh. Okay, so this is the dependency of area for the price. Okay, so you can represent this relationship y is equals to mx plus c. Okay, step number 4, use the train test split class to split data into trained and test set. Here the train test split class from scikit-learn model sklearn.model selection is used to split our data into train and test sets, where feature variables are given as input in the method. Test size determine the portion of data which will go into test set, and random state is used for the data reproducibility. So using test train split function, x train, x test, y train, y test is equals to, there are the four subset x train, x test, y train, y test is equals to, we are using here train test split method. This method we use for x and y. So x and y. There are the some other parameter like random state is equals to 104. If you want to use it, so you can just use, otherwise it will be take default value. Test size is 0.25 and other parameter is shuffle will be true. Okay. So in this example, prediction.csv file is imported. df.shape attribute is used to retrieve the shape of the data frame. It will be 13,3. That means the feature column are taken in x variable and outcome column is taken in y variable. Okay, x and y variables are passed in train test split method to split the data frame into train and test set. Accordingly, the random state parameter is used for the data reproducibility, and test set is given already given 0.25, that which means 25% of data goes into the test set. Okay, 4 out of 13 rows. 13 rows are there. We already know about the data set. Shape of the data set is 13,3. That means 13 rows are there. Okay, so 4 out of 13 rows in the data frame go into the test set. Okay, because we are using 25%, 25% of the data for the testing purpose. Okay, so 25% will be 4, I think. 75% of data goes into the training set. That means 9 row out of 13 rows will be goes for the training purpose. Got it? So the train set are used to fit and train the machine learning model. Test set are used for the evaluation. We already know training, why we use train the data. Training set always required for the training of your model, and test set are always required to evaluate your model. Okay. Yes, we already discussed about the data set. What is actually data? So data is a collection of information. We already discussed in previous slide. Here we discuss about the sample of the data. Okay, so we can see we already open here diabetic data set. Okay, and we already discussed about the iris data set as well as breast cancer data set, diabetic data set. So this is the information, basic information about the diabetic data set. We already discussed about this. Data set information, diabetic data set information, iris data set information already discussed in previous slide. So we can see here the sample of diabetic data set. So if you want to see here, there is the brief description of that particular data set. You can see a Palm Bradley, Efron, Gabriel Hasty, Eon, John Stone, and Robert Tavistriani, 2004. Okay, least angle regression and of statistics. Okay, page number you can see 407 to 499. Okay, and there is 10 baseline variables: age, sex, body mass index, average blood pressure, and 6 blood serum measurements are obtained from each. N is equals to 442 diabetic patient. That means you can say there are the information of 442 diabetic patients information, as well as the response of interest and a quantitative measure of disease progression 1 year after baseline. Okay, so you can see here variables are there: age, sex, BMI, VP, and S1, S2, S3, S4, S5, S6. Okay, so these are the 6 blood serum measurement. Okay, and BP is the blood pressure, and BMI is the body mass index. Okay, so these are the basic parameter you can say. Okay, these are the basic variable you can say which are used in the diabetic data set. Okay, so let's we take a sample. Just click on that. We already given the dataset link on the PowerPoint presentation, so you can just click on that. You will get the dataset online. Okay, so this is the information. This is the information of dataset. You can see here. First column is representing the age of each patient. Okay, second column representing the sex of each patient, and BMI body mass index represent the third column. Okay, and BP representing by the fourth column, and these are the 6 measurement. Okay, serum measurement. Okay, S1, S2, S3, S5. Okay, Y is the target you can say. There are 442 instances are there. There are 442 patient informations are there. Okay, so you can work on that if you want to use this data set whenever you want to make a machine learning model, so you can use it. Okay, another one is we use prediction data set here. Okay, so this is very small data set we use for the just take an example to data set split. How can we split the data set? Okay, so just very simple and very short data set here. You can see there are mm, serial number, first column presenting the serial number, how many entries are there, how many instances are there you can say, and second one is area. It's depend the price. Okay, so price is depending on the area. So you can see here, for example, if you want to purchase 1000 square feet house or plot in Vadodara, so price will be there. You can say see here 316404 for example. Okay, so depend on the area, you can see price will be here in the third column. So this is very simple example. We try to take this example to understand the data set splitting. How can we split the data? Okay, whenever we want to make a model. Next one is iris data set. We already discussed about the iris data set in previous slide. What is the iris data set? Oh, this is actually a flower data set. There are 5 attributes, 5 features are there you can say. First one is sepal length, and second one is sepal width, and third one is petal length, and fourth one is petal width, and last one is species. So depend on the all 4 features, you can decide whatever the flower vary in this and whatever the category. You can take an example. When sepal length is 5.1 and sepal width is 3.5 and petal length is 1.4 and petal width is zero point 0.2. That will be category in Setosa. Setosa is the class, okay, of flower. Okay. For example, second we can take here one of the another example like this one. So first column that means sepal length. Okay, sepal length is whenever sepal length is 7 and sepal width is 3.2, petal length is 4.7, petal width is 1.4. That will be in that case that flower where is the category in versicolor. Okay, so these are the example to understand the thing. Okay, you can just explore the given data set. I already shared this data set link on your PowerPoint presentation. Another example you can see here, whenever sepal length is 5.8, sepal width is 2.7, petal length is 5.1, petal width is 1.9, then in that case flower category is Virginica. Okay, so that is the third class of IRS data set. Okay, there are three classes. Okay, first one is Virginica, second one is versicolor and setosa. There are total 151 entries. You can say instances. You can say there are 151 information or instances. Okay. So whenever we deal with the IRS data set, you just explore the data set. You can just import the data set on Google platform or whenever we want to use Jupyter, okay, Spider, whatever you can use, just import the IRS data set. This is very old data set, so this is already available and will be available in the Colab as well as Spider and Jupyter also. Next thing is yes, data set split. We already discussed about the IRS data set. Okay, what is this actually, and how can we split whenever we want to develop a model? So we already discussed about this thing. Whenever we want to split the data set, so model selection will be used with along with Scikit-Learn, okay, and import the trend test split method. Okay, so firstly we import all necessary package like you can see here from Scikit-Learn dot datasets. Import firstly we import the load uh, import the iris dataset. Okay, next line is from Scikit-Learn dot model selection import trend test split method. Okay, and x comma y and load iris return underscore x underscore y, x and y, x representing the features and y representing the target, you can say. So you can say whenever you want to split, use the split trend test split method. There are four parameter are there. First one is x underscore train, y and x underscore text, and y underscore train, y underscore test. Okay, we already discussed in slide also. Okay, train underscore, this is using live example. How can we use the uh, how can we use the data split method? Okay, and here we using the Google Colab, and whatever your interest in Google Colab or Spider and Jupyter, you can use anything. So train test split on x comma y, you can see. After that we want to print here, print x underscore trend dot shape, x underscore text dot shape, y underscore trend dot shape, and y underscore text dot shape. We want to print all of these things. Okay, whenever you want to use data split method on the IRS data set. So whenever we execute this, we will get the result. That means trend shape will be 112 point comma 4. That means that is the trend shape. Okay, and 38 comma 4, that is the test shape, that is the by default value. Okay, and the trend shape is y trend shape is 112 and y test shape is 38. Now another example, we already discussed about the prediction data set. Okay, prediction data set we already discussed. Okay, so now we are using the data set where which is saved in our Google Drive. Okay, and we are using our Google Colab. So just import it. How can we import this? You can see here. First, we import the necessary package here. Import package. NumPy, import NumPy as NP. Import pandas as NP. Okay, whenever you want to calculation, number calculation, so then we use the numerical calculation, then we use the NumPy library and pandas library whenever we want to manipulate the data set. So you can use the pandas, and this is for the splitting purpose, and this is used for the visualization purpose, and as well as the Seaborn we can use for the visualization, and this is used for the whenever we want to uh, connect your Google Drive. So just import the drive here. Okay. So we use this from google.colab import drive. Here we import your drive. Okay. So this one is used along with this drive.mount. Okay. Whenever you want to import your data from your Google Drive, so mount will be there. Okay. So this one we use drive.mount from content and drive. And Scikit-Learn dot pre-processing is required here. So import label encoder is also import here. Okay. Now let's load the data set into the pandas data frame. We give here the file path. Okay. So it may be incorrect. So please give the path carefully. TF is equals to pd dot read underscore csv contain drive my drive Google Colab notebooks unit number 3 where we place the prediction.csv. Okay, so this is the path where we save our data set prediction.csv. Okay, now we want to count the head, so df.head. Okay, head of the count here we can count here, and head of the data frame, so we can also calculate this, and print df.column if you want to print column of that data frame, so you just use this, and x is equals to data frame. You already discussed, you already see the data set. There are only three column. First column is serial number, second column representing the area, third column representing the price. You already see. So x representing area and y representing price here. Using the text train split method, we decide here, and what will be the size of test data sets. Okay, so just here we taken 0.25, that means 25% data we will use for the testing purpose, and remain 75% data will be used for the training purpose. Okay, so random state we use for the reproducibility, here it will be 104, and shuffle we give here, it will be true, depend on your. Okay, if if you don't put it here, this value random state and shuffle, so it will be taken by default value, no issue. Print out uh, test set and trend set, so just print function we use here, print extend dot head, and print shape also, extend shape also. Okay, so again we use print function for print text function, x of test head, x of test shape. Again we use for print function, we use we want to see a print y train head, y train shape also, y test head and y test shape also. Whenever you run this example, execute this example, you will get the uh, head of the data frame. Firstly, you will get here. You already observed in the earlier of the dataset detail prediction.csv. Here we get the total 12 entry. Okay, there are three columns, which first one is unnamed, the second one is area, third one is price. So these are the head of the data frame. Okay, you can see here, and you can see here, these are the index. Okay, d type will be object. Okay, extend, that will be this. Okay, and x underscore text, this will be this area. Okay, and y train, this will be this. Okay, and y test, this will be this. So here we can represent the split, and we want to see all of this using print functions. That means extend head and shape, x test head and shape, y train head and shape, y test head and shape. So you will see the result. Okay,